Hello my dear students, my name is Satish Kumar. I am a chemistry faculty. Today I am here to explain previous year NEET questions. In last session we have discussed some of the previous year NEET questions. In this session we are going to discuss some more questions which will be very helpful to you at this situation, because solving previous year questions will make you understand the question paper pattern. That is very, very important right now. So now we will see the very first question. Here the number of atoms present in 98 grams of H2SO4 is X, and number of atoms present in 98 grams of H3PO4 is Y. So he is asking the relation between X and Y. So the number of atoms present in 98 grams, number of atoms present in 98 grams of H2SO4 is equals to X, and 98 grams of H3PO4 is Y. So what is the relation between the number of atoms of H2SO4 and H3PO4? So first of all, to know the relationship we need to find out number of moles. Number of moles of H2SO4 we will calculate, number of moles, right. Number of moles is equals to weight by molecular weight. Weight is 98, H2SO4 molecular weight is 98, 1 mole, right. And number of moles of H3PO4 also we need to calculate. H3PO4 weight is given 98 and its molecular weight is also 98. So it is also 1 mole, right. So both are 1 mole. You have 1 mole of H2SO4 and 1 mole of H3PO4. 1 mole of H2SO4 you have how many molecules? Avogadro number of molecules, 6.023 into 10 to the power of 23 molecules, Na means. Here this is also Avogadro number of molecules. But 1 molecule of H2SO4 you have, H2SO4 means 2 hydrogens, 1 sulfur, 4 oxygen. Total you have how many? 2, 4 plus 2, 6 plus 1, 7. 7 atoms you have. 1 molecule, 7 atoms means Avogadro number of molecules means Avogadro into 7. In H3PO4 how many atoms you have? 4 oxygens plus 1 phosphorus 5 plus 3 hydrogens, total 8. So 8 atoms. 1 molecule of H3PO4 is having 8 atoms. So Avogadro number of molecules means 8 into Na. So this is H2SO4 is X and H3PO4 is Y. How many atoms of X you have? 7 into Avogadro number of atoms of X and 8 into Avogadro number of atoms Y. So what is the relation between X and Y now? Y is greater than X, right? Y is greater than X. So the option 2 is correct. This question is from the mole concept, which is very, very important topic. From this you will get many questions. And the concepts of this particular topic is very important in other questions also. The concept is mole concept. The chapter name is mole concept. So we have calculated number of atoms. Now next question, which of the following is linear but the hybridization of central atom is sp, and the molecule is linear but its hybridization should be sp and should not be sp, not hybridization is not sp but it is linear. See, C2H2 the carbon is sp hybridized, right? C2H2 the carbon is sp hybridized, but it is linear and sp, but you should not have sp. BeCl2 is linear only, but this is also sp. SO2 is what? It is also sp having some bent shape. It is not linear even. So the final option is XeF2. See carefully, XeF2 is linear, but its hybridization is, it is having 3 lone pairs like this. Its hybridization is sp3d, not sp. It is linear, not a sp3d hybridization, right? So option 3 is the correct one. Option 3 is the correct option. Next, coming to the 159 next question. The 3D series elements which don't show variable oxidation state. You should remember this question. The 3D series element which don't show variable oxidation state is scandium. It is scandium. See, this is a D block element question, D and F block elements. See, scandium is actually 21. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1, right? So, if it is losing these 3 electrons, it is attaining next noble gas configuration, that is 3s2, 3p6. So, scandium is showing only +3 so as to get noble gas configuration. In its +3, it will be in the noble gas configuration, right? That is why it only shows this +3 and will get highest stability. It shows only the +3 and will get highest stability, right? So, that is why it will be only showing +3 and the single oxidation state. It will not show multiple oxidation state. Like other elements of D block will show multiple oxidation state for their stability, right? So, the option 2 is the correct answer for this question. Next, coming to the next question. Most stable alkene among the following. So, how can you find out the most stable alkene? Okay, by using the concept called as hyperconjugation. Hyperconjugation. The stability of the alkenes is explained by the hyperconjugation. More the number of hyperconjugative structures, more is the stability of alkene. Okay. If a compound is having more number of hyperconjugative structure, then that compound will be more stable. Then how can you calculate the hyperconjugative structures? Means, I will tell you, more number of alpha hydrogens, then more will be hyperconjugative structures. Hyperconjugative structures. Then more is the stability. Then more is its stability. So, you have to find out more, you have to find out the number of alpha hydrogens. If more is the number of alpha hydrogens, more is hyperconjugative structures and more will be the stability. See now, where you will be having more number of alpha hydrogens, you can see this double bond, that is the very first option I am seeing. This is the first option. So, it is having 2 alpha carbons. The carbons which is adjacent to the double bond is alpha carbon. Hydrogens present on the alpha carbon is alpha hydrogen. If you can calculate here, in the first option you will be getting 6 alpha hydrogens, and in the second option you have only 1 alpha carbon. On this carbon you do not have any alpha hydrogens. So, 0 alpha hydrogens. And you can take third option. Third option you will be having only 1 alpha carbon. On 1 alpha carbon you have 3 alpha hydrogens, and in fourth is also 0. So, more number of alpha hydrogens you find in the first option, right? That is why the first option is the correct option. As it is having more number of alpha hydrogens, it will be having more hyperconjugative structures, and more hyperconjugative structures means more stability, right? First option is a compound having more stability, right? And see the next question. This is tertiary methyl carbon here. It means tertiary methyl carbon, sodium alkoxide. This is what? Sodium alkoxide reacts with ethyl iodide. So, what will be the reaction he is asking? It is very simple reaction. I will be expanding this structure, CH3, 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 O, sodium alkoxide. This is sodium alkoxide. Tertiary butoxide. This is known as tertiary butoxide. When reacts with iodine in presence of C2H5i, ethyl iodide, simply NaI will be removed from it. so as to get CH3, CCH3, CH3 and O(C2H5). This is tertiary butyl ethyl ether. Tertiary butyl ethyl ether. This particular reaction is called as Williamson ether synthesis. Williamson ether synthesis. What do you mean by the Williamson ether synthesis? Sodium alkoxide is taken and reacts with the alkyl halide to get an ether. This is known as Williamson ether synthesis. Okay. And so the answer is tertiary butyl ethyl ether, that is third option is the correct answer for this question. Is asking the product, right? And next, coming to the which gives immediate turbidity with HCl and anhydrous ZnCl2. So generally alcohols reacts with RCH2OH plus HCl in presence of ZnCl2 will give RCH2Cl. Again I am writing R2CHOH reacts with HCl and forms R2CHCl, and also R3COH also reacts with HCl and forms R3CCl. See, in all these reactions it forms alkyl halide. This is nothing but a turbidity, but the reaction occur very fast in case of tertiary alcohol. Alcohols reacts with HCl and forms alkyl halide, and alkyl halide itself is a turbidity, but tertiary alkyl halide reacts very fastly with HCl, because in case of tertiary alkyl halide it will be like this. All our electron donating groups will donate the electrons to the carbon chain, so OH will be removed very easily, as a result of which you will be getting carbocation very easily. So that Cl minus will attack very easily and forms turbidity very easily and forms turbidity immediately, right? That's why tertiary alcohol will form the turbidity immediately with HCl. So here in the given option the tertiary alcohol is what? Tertiary alcohol is first option, right? Tertiary alcohol is the first option, right? And this question, see, this question is from solutions chapter. This is a very first chapter in the second year physical chemistry, right? So two liquids A and B he has, right, form an ideal solution if the mole fraction of A in vapor phase is 0.4, then the correct relation between PA and PB. So partial pressure he is asking. Partial pressure of A is equals to total pressure into mole fraction of A by, if you are dividing the partial pressure of A with partial pressure of B, partial pressure of B is equals to total pressure into mole fraction of B, right? Total pressure into mole fraction of B. Total pressure will get cancelled. So that partial pressure of A by partial pressure of B is equals to XA by XB, right? So partial pressure of A by partial pressure of B, PA by PB is equals to XA is given as 0.4. And what will be the XB, mole fraction of B? You have two components and sum of the mole fractions of two components, XA and XB, sum will be 1. So A will be 0.4 means B will be what? 0.6, because sum of the mole fractions of all the components will be 1. Here two components are, one of the component will be having the mole fraction 0.4, right? The other component will be 0.6. So we will be cancelling this 0 points, and here we will write 2 times and 3 times, so that you will be writing PA by PB is equals to 2 by 3. This we are going to write it as what? 3 times PA is equals to 2 times PB, right? That is the option 3 is the correct. And next, coming to the 169, most basic among the following based on the inductive effect. So, basic nature of amines this is again from general organic chemistry. Basic nature of amines was explained. Basic nature of amines was explained. Basic nature of amines was explained by what? Inductive effect, right? 𝗏𝗧 group. 𝗏𝗧 group increases basicity and -I group decreases basicity. +I group increases basicity and -I group decreases basicity. So, here these all are +I groups only, but more the number of R group is a +I group, alkyl group is +I group. So, R3N means it will be like this R. So, more electron donating groups will be there, because of which more electron density on nitrogen. If electron density is more, it is more basic in nature. If you compare this with R3N with R2N, RNRH here less number of electron donating groups. Less number of electron donating groups means the electron density get decreased. So, most basic is R3N, next R2N, next RNH2, next is NH3. So, most basic is R3N. If electron donating group is present on the nitrogen, its basicity will be increasing. Okay. So, option 1. Next 175, which reacts with 𝗂𝗏 reagent and gives a compound insoluble in NaOH. So, this is the chapter organic compounds containing nitrogen, particularly from amines, generally primary amine and secondary amine react with 𝗂𝗏 reagent. React with 𝗂𝗏 reagent. Tertiary amine do not react with 𝗂𝗏 reagent. Why means tertiary amine do not have hydrogen. How it will be reacting like? See, RNH2 means I am writing NHH. 𝗂𝗏 reagent is benzene sulfonyl chloride. Benzene sulfonyl chloride. This H reacts with Cl and forms HCl. RNH S double bond O benzene. This is the product of 𝗂𝗏 reagent. But it is soluble in base because of one more H is present. This reacts with OH of base NaOH. If you react with this, it reacts with OH, this H reacts with OH and forms H2O. It means the product of this reaction dissolves in NaOH. What is the amine we have taken? Primary. But if you take secondary amine RNRH and react this with the 𝗂𝗏 reagent, so this is benzene sulfonyl chloride 𝗂𝗏 reagent. What you are going to get is RNR and S double bond O and benzene. Here you do not have any hydrogen which will be dissolved in base. In base OH minus will react with H plus, but you do not have hydrogen. That is why this secondary amine reacts with 𝗂𝗏 reagent, but insoluble in the base. So, in the given option, aniline is a primary amine, N-dimethyl aniline is a tertiary amine, N-methyl aniline is what? Secondary amine. N-methyl aniline is a secondary amine. That is why N-methyl aniline do not react with what? Do not dissolve in NaOH, but it reacts with 𝗂𝗏 reagent. But do not dissolve in NaOH. Next, for cis-2-butene and trans-2-butene, which of the following properties is common? For cis-2-butene and trans-2-butene, trans is having more boiling point than cis. Dipole moment. Cis is having more dipole moment than trans. Heat of hydrogenation. Trans is more stable, that is why trans is more than cis. But product of hydrogenation is same. Product of hydrogenation means, see, He is asking which of the following is same. He is asking CH3, if you have taken H, this is his compound, and trans of it is CH3, H. If you have react this with H2 and H2, you are going to get is CH3. Already H is there, one more hydrogen is added, one more hydrogen is added. Here also CH3, H2. You will be getting same compounds. If you are adding hydrogen, you will be getting same compound. So, the product of hydrogenation is same for both cis and trans. But remaining all other properties are different. You just have to remember this. These are very important. Boiling point is more for trans than cis because more stable. Dipole moment is more for cis than trans. Heat of hydrogenation is more for trans than cis. This you will get questions. This is also important. But your correct answer is fourth option. He is asking same. Product of hydrogenation is same for both cis and trans. Okay. So, this is again isomerism question based on the isomerism, right? And see the next question. Coordination number of central metal atom ion in this compound is. Coordination number means what? Generally the coordination number. This is complex compound question. This question is from complex compound. So, what do you mean by the coordination number? Coordination number. So, the number of dative bonds that central metal atom will form is called as coordination number. Number of dative bonds that central metal atom forms with ligands is called as what? Is called as coordination number. Here how many dative bonds that calcium can form here? This is a hexadentate ligand. What we have taken EDTA is a hexadentate ligand. Hexadentate ligand, that is why it will form 6 dative bonds. So, calcium forms 6 dative bonds. So, coordination number is 6. So, option 4 is the correct answer for this question. Next, coming to the enthalpy of atomization in 3D series is least for. So, enthalpy of atomization means what? Enthalpy of atomization. Okay? It is the energy required for the making an atom from its element or its metallic state. So, those elements which are having weak metallic bond can form atom very easily from its combined state. Because metal, you take iron metal, iron atoms are bonded with each other with metallic bond. If your metallic bond is very strong, we can hardly separate the metal from its element. If metallic bond is very weak, by supplying less amount of energy, we can bring out its metal atom, right? So, metallic bond is weak. Which one is having weak metallic bond? Tell me. Which one is having weak metallic bond? Zinc is having very weak metallic bond. Why zinc is having very weak metallic bond means, as number of unpaired electrons are less, unpaired electrons less, metallic bond strength also less. Metallic bond strength will also be less. Metallic bond strength will also be less. Here when you take zinc, you don't even have any unpaired electrons. We don't even have any unpaired electrons, that is why it don't form a strong metallic bond, the zinc metal. So, it forms a very weak metallic bond. So, its atoms can be formed very easily with less amount of energy. That is why enthalpy of atomization of zinc will be very, very less. Okay. And next, this one. X is an element whose mass number is 249. X is an element whose mass number is 249, which is reacting with calcium and forms oganesson 118, 294 and 3 neutrons. 3 neutrons, its charge will be 0 but mass is 1. So, what will be X? x will be 98, x should be 98. 98 plus 20 will be what? 118. So, it will be californium. Californium 98, 249 reacts with calcium 2048. So, as to get 294 augneson and 118 is the atomic number. And 3 neutrons, and neutron charge is 0, mass is 1. Okay. This one, this is the last question of this session. Compounds you have like PtCl2NH3 taken for Br2 and PtBr2NH3 taken for Cl2 shows which isomerism. So, PtBr2, these are ionization isomers. Why these are called as ionization isomers means, see the first compound is PtCl2NH3 taken for and Br2 outside. If you ionize it, you will be getting the following ions: PtNH3 taken for Cl2 inside as it is. Here we will write +2 and we are going to get 2Br minus. And the other compound, if you take Pt, Br2 inside, NH3 taken 4 as it is, and this time you will be having Cl2 here. If you ionize it, you will be getting Pt, NH3 taken 4, here we will be writing Br2 inside and 2Cl minus outside. So, +2 here. Upon ionization, what you are going to get is, here Br minus you got, here Cl minus, here outside Br minus, that is why we have written Br minus. Here outside Cl2 we have written Cl minus. Upon ionization, what we have got is, we have got different ions. Okay, so that is why we will be calling this as ionization isomerism. Those complex compounds which will give different ions, different types of ions upon ionization, then we call that complex compounds are exhibiting ionization isomerism. We know that the complex compounds will exhibit both structural isomerism and stereoisomerism. In structural isomerism, we have different types of isomerisms: hydrate isomerism, ionization isomerism, linkage isomerism and coordination isomerism. And this particular ionization exhibited by these compounds will be ionization isomerism, because upon ionization we will be getting different ions. So, to identify the ionization isomerism, do we need to do all these things? No, it is not needed. By seeing the compounds alone, we can able to say whether it is exhibiting ionization isomerism or some other isomerism. How can you say the ionization isomerism? How can you identify the ionization isomerism? By seeing its compound formula, means outside the square bracket you have Br2 here, you have Cl2 here. If outside the square bracket, if you have different atoms or different ions, then it will show the ionization isomerism. Here Br2 is different, Cl2 is different, that is why it will be showing different ions. Upon ionization, it will be giving different ions also. So, then we will be calling this as ionization isomerism. Okay. So, these are all the questions that we have discussed in this session. Okay, all of you practice the previous year questions and try to take the reference of these questions. I have just covered some of the topics and some of the questions only. We have many kinds of questions that have been asked in the previous years, and almost same models of questions are going to be get in the next examination also. So, all of you practice that questions. Okay, thank you very much.